Hi, everyone. First of all, thanks to the organizers of
Very
this
loud,
lovely
very loud. Turn
conference.
it down.
My name is Alessio, and I'm a lecturer at Royal Holloway, University of London, and I'm also currently a visiting fellow at Princeton. And I'm here today to talk about HiPeople. The name stands for Hyperfast Inference with a Probabilistic Programming Language. And as the name suggests, the idea behind this software is to create a new framework for both hierarchical likelihood-based inference, such as field-level inference in cosmology, and simulation-based inference. And the idea is to do so by using a probabilistic programming language, in particular, a combination of the JAX and NumPyro libraries, which allow the user to create efficiently forward models that are by construction fully differentiable. In particular, for applications to cosmology, HiPeople seamlessly integrates with COSMOPOWER, in particular in its JAX variant, and JAX-COSMO for the computation of cosmological observables in a fully differentiable way. And by the way, if you haven't done so, please do check out Davide's poster on COSMOPOWER-JAX. Armed with these tools, the user of HiPeople can efficiently and simply create pipelines that are completely differentiable by construction and use them to perform both hierarchical likelihood-based inference and simulation-based inference. And for the latter, multiple compression techniques are implemented in HiPeople, including information maximizing neural networks, score compression, and many others, all enhanced by having access to a forward model that is by construction fully differentiable. In these 3 minutes, I only have time to show you one cosmologically relevant example, and this is an application to supernovae. This is a Bayesian hierarchical model which is inspired by the Bahamas model, and as you can see from its probabilistic graph, it is a fairly complicated statistical model for each of the supernova in the sample. There are multiple parameters and latent variables. And in this plot, I'm showing posterior contours obtained running HiPeople, both with a likelihood-based Bayesian hierarchical model, as well as using simulation-based inference. And you can see that these posterior contours, which have both been obtained in just a few minutes running on a GPU, match very well with each other. I'd like to finish off with an advertisement for a discussion meeting on simulation-based inference in astrophysics to be held at the Royal Astronomical Society in London in January. You're all very welcome to attend, both in person in London if you can, or online. And thank you very much for your attention.